but they are very unstable and very highly reactive. To talk about radicals, let's talk about orbitals. Orbitals can be in one of three states. The orbital can be empty, the orbital can be filled with electrons, or the orbital can be half filled with electrons. When an orbital is empty, it has 0 electrons in that orbital and can often be a cation. It doesn't have to be a cation, but it is often a cation if the orbital is empty with 0 electrons. Examples would be the hydrogen cation, what we call the proton, or a methyl cation. A methyl cation is a carbon attached to 3 hydrogens, where the central carbon has 1 orbital that's unfilled and is a cation. Or it could be something like borane. Borane is boron attached to 3 hydrogens. The central boron has an orbital that has 0 electrons in it. However, in this case, boron is neutral. It doesn't have to be a cation, but it's often a cation. Another case could be where the orbital is filled. And when it's filled, then it has 2 electrons. And when it's 2 electrons, those electrons can either be in a bond or a lone pair. And can sometimes, when the orbital is filled, can sometimes be an anion. Not always, but sometimes can be an anion when the orbital is filled. Examples of this would be the hydride anion, hydrogen with 2 electrons and a negative charge we call the hydride anion, or H2 gas, where the orbital forming the bond between the 2 hydrogens is filled, has 2 electrons in it. Or it could be something like the methyl anion, where carbon has 3 bonds to hydrogen. All of the bonds have 2 electrons in them, so those orbitals are filled. And the carbon has 1 more orbital that has 2 electrons in it and gives it a negative charge. Or it could be something like water, where oxygen has 2 bonds to hydrogen. There are 2 electrons in those bonds, so those orbitals are filled. Oxygen also has 2 additional orbitals. Each of those 2 additional orbitals has a lone pair in it, and so those orbitals are filled as well. But the subject of this video is what I want to talk about today is a half-filled orbital. A half-filled orbital only has 1 electron in it, and we call it a radical. We call that molecule a radical, and we call that atom that only has a half-filled orbital a radical. Examples of a radical could be a hydrogen, where the orbital only has 1 electron in it rather than 2. This is called the hydrogen radical. Or a methyl radical, where we have carbon attached to 3 hydrogens, and that carbon has an orbital that's only half filled with only 1 electron in it. Or we could have the hydroxyl radical. Oxygen's forming a bond to hydrogen. That orbital has 2 electrons in it. Oxygen has 2 more orbitals with lone pairs. Those are filled. But it has 1 more orbital that's only half filled with only 1 electron in it. Or we can have a bromine radical. Bromine here has 3 orbitals that have lone pairs, and so those are filled, and 1 orbital that has only 1 electron in it and is half filled. So the 1 electron system, the half filled orbital, is called a radical, and that's the subject of this video. So what about radicals? Radicals are orbitals with only 1 unpaired electron. An orbital typically has 0 electrons or 2 electrons in it, but in a rare case, it can have 1 electron where that electron is unpaired, and we call that a radical. The orbital for hydrogen would be the 1s orbital. So that 1s orbital on hydrogen, if it has 0 electrons, then it's the hydrogen cation. If it has 2 electrons, it's the hydride anion. But if it only has 1 electron, then it is the hydrogen radical. For carbon, if we look at carbon, a carbon radical would be sp2 hybridized. So it would have 1 bond to hydrogen, 1 bond to hydrogen, and 1 bond to hydrogen, where each of these 3 orbitals are sp2 hybridized orbitals. This is all in a flat trigonal plane, where this plane is assumed to be going perpendicular to the board. And there's 1 p orbital, and that p orbital only has 1 electron in it, and that 1 electron is unpaired. So the carbon is sp2 hybridized, and the p orbital is the orbital that only has 1 electron, the 1 unpaired electron in it. What do we need to know about radicals? Radicals are unstable, so that means they're very reactive. We don't learn very many reactions that involve radicals in this course, but when we do, those radicals that we form are going to be highly reactive species, highly reactive intermediates. But what's interesting about radicals is that electronically, radicals have a neutral charge. That's almost a bit of a paradox. You would think that if something had a neutral charge, then it would be relatively stable, or if something was highly reactive, then it should have some kind of charge. But if we look back at our radical systems, hydrogen wants 1 electron in its ground state valence shell configuration, and it only owns 1 electron. 1 minus 1 is 0. Hydrogen is neutral. Carbon wants 4 electrons in its ground state. It owns 1 electron from each of the bonds and 1 in the radical, so it owns 4 electrons. 4 minus 4, this is also neutral. Oxygen would want 6. It owns 1 from the bond, 1 from the radical, and 4 from the lone pairs. That's also 6. Bromine wants 7, and it owns 7 electrons. So all of the radicals are neutral, but they are very unstable and very highly reactive. This is just a primer, just an overview of radicals. We'll learn a lot more about them throughout the semester, but this will get us started into what radicals are and why they are important in organic chemistry.
Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.